In this example, we're going to graph the following function, which may look scary at first, but then you'll see that this is very, very similar to how we graph quadratics, absolute value functions, and other types of curves from our toolkit function. So the only thing we need to do is add to our toolkit function now the function log of x. So here I wrote log, so it's implicitly it's log in base 10. Okay, and so we're going to start with that. So recall, if I have f of x, which is log of x, its graph is going to look like this. Okay, so this has to be somewhere in your memory cell. Actually, you don't actually need to remember this. If you remember 10 to the x looks like this, like again, like I said, you could just need to reflect it across the line y equals x, and then you get the graph of log of x. So this goes, of course, through 1, 0. So what we're going to do is sort of modify this graph, okay, to graph G. So we're going to do some transformations. And if all you have to do is realize that this g of x can be written as minus 2 f of x plus 3 plus 1. So it's really of the form, again, a f of x plus h plus k. And as soon as you see this, you're like, oh, okay, I can do graph quadratics that way. I can graph absolute value functions that way. Well, that means I can graph other types of functions that way. And then the parameters, they're all responsible for the same thing that they were responsible before. So the 3 here, okay, since it's x plus 3, that's responsible for a shift of 3 to the left. The plus 1 is responsible for a vertical shift of 1 up. And this guy here, the minus 2, does two things. The 2 performs a vertical stretch, and the minus flips the graph around about the x-axis, because now all y values will change sign. So this is going to be vertical stretch of 2 and a reflection across the line, across the x-axis. Okay, now we have to perform these in the right order. You see the plus 1, the vertical shift is done last. So maybe first thing you want to do is maybe shift. We could do that. Shift first, then do our vertical stretch. So that affects the f, and then after that we add a term. We add 1. So that's done last. The vertical shift is done last. If you don't respect the order, especially not doing a vertical shift last, you're not going to get a right graph. If you do invert 1 and 2, that doesn't matter. Okay, you could do your vertical stretch and reflection first, and then shift. That's okay. You could do, but 3 needs to be 3. Okay, so we're going to do this. So number 1, maybe let's do that first. Shift 3 to the left. So we take our graph, okay, and we shift it 3 to the left. So since the y-axis is an asymptote, that's going to be shifted too. So maybe let's start with that. We're going to shift our asymptote. So now x equals minus 3 is the new asymptote. 1, 0 is going to go to minus 2, 0. And then we can just... okay, and then now it's going to have a y-intercept. We can add it, actually. Why not? So remember, now we're graphing log of x plus 3, right? Because we're just doing the shift 3 to the left. So replacing x by 0, we get 0 log of 3 here. Okay. Now we're going to do our vertical stretch and reflection. Okay, so that's not going to change the vertical asymptote we have here. So we can still, okay, graph it down. Now I'm going to, I could reflect and stretch, so maybe I can stretch first. So if I stretch, the minus 2, 0 stays where it is, but it's this guy that's going to be twice as high, so I'll have 0, 2 log of 3. Okay, so it's going to look like this. But remember that I want to actually reflect the 2 across the line y equals x. So this guy here is going to go all the way over there. This one will stay where it is. So in fact, my graph will look like this. Okay, so this is going to be, let me erase it. So this point here now is 0 minus 2 log of 3, and this is still minus 2, 0. Like that. So now I have graph y equals minus 2 log of x plus 3. And finally, all I need to do is shift that 1 unit up. So the principles of graphing functions just apply here. So there's nothing more difficult. It's just that we start with a different toolkit function. But apart from this, same thing. So minus 2, 0 will go to minus 2, 1. So it's not going to be the x-intercept anymore. This point here gets shifted a little bit, so that's going to go to minus 2 log of 3 plus 1. And this is going to have a new x-intercept that maybe we want to calculate. I'm not sure if we can, though. Now I realize I wasn't careful enough. So this guy here, I maybe I should have calculated just to see where it is. So what's minus 2 log of 3? This actually turns out to be actually 0.95. So when we're going to add 1 to that, okay, when we're going to shift that 0.1 unit up, it's going to actually go above the x-axis. So I've put it down, but it's going to go actually here. So I should have been a bit more careful. So I need to erase this, just to make the graph actually look the way it should. There we go. Like that. So it's going to go through 0. And I'll just write down approximately what it is. So if I, oh, this is minus 0.95, by the way. So if we add 1, it's going to be 0.05. It's actually very close to 0. And our graph is going to go like this. So actually my x-intercept will be here. So I can actually try to find it. I know there's only one, so all I need to do is make y equal to 0 and solve for x. So the equation is minus 2 log of x plus 3 plus 1 equals 0. So and I'm going to solve this for x. So we're going to spend more time doing that in a following section, but I'm going to do it here. We can actually do it just to show you. We're going to bring the minus 1 on the other side. I'm going to bring the minus 2 on the other side, so divide by 2. So that's going to give me 1/2 here. And now I've got a logarithmic equation, and I'm going to convert this into an exponential equation. So remember, this is log n base 10. So 1/2. So a log is a power, right? So is an exponent. So 1/2 is that exponent. So 1/2 is the exponent to which I raise the base, so 10. In order to get x plus 3. So now I've converted that equation into an exponential equation, and now I solve for x. So it's 10 to the 1/2 minus 3. And this is approximately equal to, so 10 to the 1/2 is square root of 10, right? So we can write it like that. Square root of 10 minus 3. So it's a little bit above 0 because square root of 9 is 3. So square root of 10 is 3.16, so I subtract 3 from that, I get approximately 0.16. So this is actually completely equal. So it's 0.16. So this is going to be 0.160. And that's the graph of our function. It's not that complicated. So you just need to add the logarithmic function to your toolkit functions. And then from this, you can graph pretty much anything that involves the same parameters we've been using so far. So just to make this a little more obvious, I'm going to write that down for you. Add to the toolkit functions.